Hello, uh, hello everyone. Uh, Welcome back to transport modeling plan 252. Uh, okay, so the agenda for today. Okay, I saw some of your assignment. Okay, so what happened to your car following assignment? Is it difficult? Do you know how to animate? Any feedback? Anyone? Oh, can you hear me?
Yes,
Yes, sir.
yes, sir.
We can hear you.
Okay. So is there any feedback from your assignment or following assignment?
Sir, for the car following assignment, I think the deadline set online was on September 27 and not today.
Okay, not today. Okay, good.
So I think that was the reason why most of
Why you
us
keep
did not yet
silent?
submit.
Okay. Uh, okay then. Like this. Okay. I have the example of spreadsheet. Okay. Can I show you the screen? So do you want to download this? Yes, we can demo the animation. So I will show you. Okay, when you download this, okay, I will download this. There. Right, let's open that. So this is, of course, the assignment should be more than just two vehicles, right? And not only using the T, but you need to add additional, isn't it? Yes, Joven, you want to say?
Just clarify, sir, the deadline was moved
No? Hmm?
because last meeting you said the deadline was today. So I submitted with incomplete.
Oh, let me check the deadline.
Sir, in the calendar, it says it's on the 27th.
Okay, let me see. Yeah, it's 26. Yeah. In 26 September.
So it's the same with the IFN, sir.
IFN?
We have another homework, sir, the IFN.
Okay. Yeah, but this is already several weeks ago, right?
Yes. So I thought, sir, the deadline was today because the IFN is next week.
Okay.
So I just submitted incomplete.
No problem. You
with
can
incomplete.
resubmit again. No problem.
Okay, sir. Thank
Okay.
you.
Okay. Let me show you the Excel. Can you see that? Okay, enable editing. What? Okay. So this is the input. Basically, this is from this one. Okay, this is the first vehicle speed, and then this is the second vehicle speed. This is the acceleration of the first vehicle, because we put zero all. This is the acceleration of our second vehicle. Initially, we don't have, so, and then we compute this, okay, based on the previous value of the velocity, okay, divided by this PF time, reaction time. and so on. So this is just the relative speed. So between the first vehicle and the second vehicle. Can you see that? Okay. And then now this is the position. Okay. So position means the previous position plus the speed, the average speed. So the previous speed and current speed divided by 2, right? So the same thing here. Okay, so this is the position, meaning this is the previous position plus the previous velocity and current velocity divided by 2. Yeah. So very simple, right? And then this one is just spacing, so between the two positions, relative spacing. So all of this, after that, once you have this, so you just go. Oh, why did I know it wrong? So, and then you can plot all of this, right? So the spacing versus time, the relative speed versus time, and the position versus time, right? Now, probably what you think you cannot do is the animation, right? But in fact, you can do it easily. Okay, so first you create a control. Control is just any cell. Okay, you just put name here, stop, for example. Later you just delete. Okay, and then give a name here. Can you see the name box on the left? Can you see my mouse? Here, the control name
Yes,
box.
sir.
Okay. Nah, and then what you need to do is just create the time and then the row and then the position, right? So because this is a table that you have created, okay, so then you can put the time like this, okay. If the control is empty, okay, and then so this is yes, Jogan.
Sir, why is the time axis like that, sir? Because the time given is 0, 1 to 15.
I thought you want to make animation. You want me to
No,
animate
the
first? Okay,
spacing, the relative
okay,
speed,
okay.
sir.
I will show you the animation first. Can you see this?
Okay. Okay, sir.
Okay, so there. Okay, and then you can start to see the animation. Animation, this is the time 5, 7, 8, right? So this is the relative position basically. Okay, you have downloaded, right? Okay, all you need to do is just delete this control file, control cell, and then press F9 to animate. Is there any error? Does it work?
It's working, sir.
Good. Do you want to know how it works? Okay, you practically can create animation in Excel. This is the one of the simplest. Okay, so the technique is called iteration. Okay, so Excel has iteration but hidden, so you don't know probably. So okay, so the way to do is you create a control cell here. Okay, empty cell basically. You can put any string. So I would stop here. Okay, and then you create the time. Okay, so this is the key. Look at this, the time cell is S4 in my case. Can you see? The location is in S4, right? So then look at the if then here. If the control cell is empty, Now S4 plus 1, meaning itself plus 1. Otherwise, make it 0. Do you understand the meaning? Means, okay, when I delete this control cell, it will become 1, right? Because initially 0. Whenever I put here not empty, so I put A, for example, it will become 0 again. That's how you control the cell. Clear or not? Right? So then, whatever you delete in here, that it will become 1. And then whenever you recalculate, that's mean in Excel, recalculate is F9. So you can use also in formula here, there. Okay. You can also click this one, recalculate now, there. Okay. This is the same as F9. So it will increase the time step. So how it works, okay? So this will only work if you set iteration. The iteration set is here, okay? Go to the file, option, okay? In the formula, there, this is the key. Can you see this? Enable iteration computation, and then you change this one to 1. And then click OK. That's it. Okay. So once you can make this, okay, this one is easy. This is just the matching. Yeah. What's the meaning of matching? If this is the time, right? So now I need to match in the table, right? So based on this time, where in the table? Okay. What is the row? What is the row number? Of course, the row number is here, right? So if the time is 0, this means I just get the row in that table. So row 7, right? In that case, the next one is just index. That means I want to return this cell, okay, based on that row. Any question? You try first so that you know. And how to automate? You need to manually click calculate now. I think one of you also asking about so if you type multi-agent system in Revolut, yeah, you can also see this, okay, and you can also see the you can just download the file. This is also similar. Okay, so you click enable. Okay, all you need to do is just this delete this stop control, okay, and then press F9 or calculate now. Now can you see the agent start moving? This is just simple race between say horse race. Yeah, oh, that one is the winner. Cool. So benefit pack, comment, any difficulty? So no problem. Okay, the assignment you just need to add several columns. Okay, to make it general, and then to make several vehicles, for example, 3 or 4 vehicles. Then you plot the position of these 3 vehicles to animate. Are you okay with that? Of course, you can also do more. Okay, so where is my car following model? You can find the latest car following model. I think in Revolut car following. Following. Okay, 1, 2, 3. Oh, why I cannot find the link? Okay, later I will add the link if I cannot find. There is a link on the animation last time. Oh, here it is. Okay, so here. So you go to Revolut model. Okay, below the course syllabus, there is an example of macroscopic animation. Right? So, and then you click this. And you see if it works. Oh, it doesn't work. I'm not sure why it doesn't work. Oh, there it is. Can you see? So this one I have many lanes. So in your spreadsheet is only one lane. So the idea, okay, is to put many forces here. So I give you example. Okay, I will remove all the forces and check all. The other forces, right? So I will uncheck all except the goal force. Okay. So the display I will remove the trail and here. So this is how it works. Put the zoom over. I will put this road stop and play with the zoom level. I think I need to make it a little bigger. Stop and play. Can you see? So I set the destination here. So you can set so that you can see how it works. So I put left and right. Stop and play. There. Okay. So we set the initial position, so it will generate it around here. And then it will be removed around this point. Can you see that? Okay. Then you can generate and then remove here. So the force is rather simple. Okay. If you know the initial position and the final one, Okay, and then you just divide into many part, okay, and then put that into acceleration. Okay, so if you know the position and you know the target, okay, so that's become the desired motivation. Okay, that's become the force, and then now that force now divide into many time steps. Okay, then become acceleration. Is it clear or not? Any question? Yes, June.
Sir, is this the same as the one that you presented in Excel or
In?
in Excel a while ago?
Yeah, this is the same, but the difference is this is more comprehensive,
Mhm.
okay? Because this one now consists of I did not make the if you want to download this as animation, you need to add additional tools, but I did not make it yet for us. Okay, this is just canvas. Okay, so the idea is the same as the one in spreadsheet a while ago. Okay, in the spreadsheet, right here, can you see the spreadsheet? So what you have is here, initially this one, right? And what you animate is, this is the position of the vehicles. Okay. So this is the one that we just put the rectangle there in the animation. In here, I just put circle, right? So can you see? I put, say, initially 0 and -50. Okay, can we see this in the actual value here? 0 and -50. Right? And then when you delete this control cell, okay, now become 10 and -48. That is the second row, yeah? 10 and -48. Can you see that? Okay, and then the third one, when you calculate now become the third row, which is 20 and 42. So yeah, it's for -42 and 20 here. So this is how you animate. Correct? And so on. So because this is using table, okay, at certain point your table is no more, then it will become error. So I give you example here. Let me continue. At certain point, it will become error because no more row in the table. There. Can you see? This is the problem when you use table, unless your table very long. Okay? So no more rows in the table, then you cannot throw. So in the next sheet, in the same output, so here we use exactly the same technique. Okay, instead of making a table, now we change this into a buffer. And this is the one that you can use in the actual program. Yeah, this is the machine inside. So in the buffer, you just copy. Okay, if the control cell is empty, then copy the second one. Okay, otherwise use the first line. Yeah, times 0. Right. So this one is exactly the same. So copy for all. And this is the actual things that you simulate. So the formula is exactly the same as a while ago here. Okay? But the difference is now you put if. Yeah? So you put if here, if the control cell is empty or not. Right? So that's the only difference. So if the control cell is empty, so you get from the buffer, otherwise you get from the initially you get from the time 0. Is this clear? And then once you have that, so this one you just get equal to this position in the buffer. This one also you get from this position, right? And then you can just delete the control cell, and then it will run practically forever. Okay. You can just press F9. Okay. Okay. Is it clear or not? Yeah, this will not have a limitation of the table. Yeah, eventually, okay, the spacing will be stable around 55. Yeah, but be careful, okay. This model is using iteration, so the result will be slightly different from this table. Yeah, why? Because the Excel way to compute is from the top down, from left to right. So for example, if this cell you put it in here, you put it up here, okay, sorry, so it will not work correctly. Okay, so the position of the cell matters. Okay, for example, here, initially correct, but when you put like this, see, it will not work. Okay, why it will not work? Because this is computed first before the simulation, because this is on the top. So to overcome that, you need to put this down here. Is it clear? The way Excel compute is from the top to bottom, from left to right. Okay. So if you put the position, this one on top and then the computation down, so it will not work, because how can you output first before you compute? That's the way. Why it doesn't work. Okay, give me questions so that you become clearer. If you have any doubt, you just ask. So I give you the example of two vehicles, you just make it more general. Okay. Very quiet, meaning you understand or you don't understand, I don't know. Anyone want to say anything? Okay, so this can I assume this is okay? You can just use the animation there, and you can play around with all the other things there. Yeah, there are many. You can create your own vehicles and a road and different parameter there, yeah, a lot of parameter that I add more than the Excel model. Okay. Okay, then let's go back to the model. Okay. Our next topic today is about network representation. So this is macro level. Okay. You can go to the model in the part of transport supply analysis. Yeah. So this is a new topic. There, you open this network representation. Okay, and you can also open the network and matrix here. Okay. So this is the lab of network and matrix. And the slide is this one. Okay. So today we'll go to the very basic, okay, of network representation. Okay. There are several ways to represent a network. Yeah. One way is to use what is called adjacency matrix. Okay. Other way is to use adjacency list or use the string later. So adjacency matrix is basically node to node. Yeah. So from node to node is a link. Okay. So the content of the matrix is either binary or certain weight. Okay. So we will use what is called MATLAB notation. Okay. That means you use comma to separate the matrix entries between the columns, and then you use semicolon, okay, to separate the rows. Okay. So I give you example. This is the example of a network. Okay. And this is what is called adjacency list. Okay. So here, can you see? Okay, so we start from A, this is from, okay, and then to B, and you see this is from A to B. Yeah. So 1 here is the weight of A to B. And then from B, so before the colon here, mean before from B to C, this one. Okay, the weight is 1. And then from C, this one, to D, okay? And then from D to B, 1. Yeah. And then from E, you have 2. Yeah. So go to A and go to B. Is it clear or not? Okay. Next. Oh, how about if we
Sir,
want? Yes.
sir, I have a question.
Oh, go.
Why is that the weight from E to A and E to B are the same?
In here we use the same weight. Yeah. In this example, we use the same weight, meaning 1. Okay. The weight must be positive. So you can put any number. Okay. In here, we can use just 1. 1 means there is a connectivity. Okay. Okay. So why this is equal? You can this is just example. So you can put not equal. Later I will show you something that not equal. Okay. Wait. So So this kind of representation is called adjacency list. Yeah. We can also make adjacency matrix. Yeah, so this is another example of network. Okay, and now this is the adjacency list, and this is the adjacency matrix. Yeah, so adjacency matrix mean from, this is from, and then this is to. You can see the arrow here. Okay, so here from A to B is 1, right? So here from A to B, 1. Okay. And then from B to C and to D. See here, from B to C and to D. Clear, yeah? You can also see here, yeah? From A to B, this one, and then from B to C and to D. Yeah. And then from C, go to E. So this one from C, go to E. This one, yeah? Oh, from D, nothing. But you still need to put like this in the adjacency list. Why? Because otherwise I will not know that D exists, right? Okay, so from D, if D exists, okay, but there is nothing there. Okay. And then from E, go to two nodes, yeah, from E to A and B. This one. So here also from E to A and B. Can you see the connectivity between the adjacency list and adjacency matrix and the network? Easy, yeah. So now look at this point D. Yeah, point D. Yeah, this is called a sink. Yeah, you know, like the sink basin. Okay, when you put water there, okay, going inside but never go out, right? So it drain your water. Yeah. So you can see if there is a node that can only go in and cannot go out. Okay, then you will see no outlink. Yeah. So D here empty, correct? In the adjacency list, in the adjacency matrix, you will see in the row all 0. That's the characteristic. Yeah. So even without the drawing, okay, looking at the matrix alone or the adjacency list alone, you will know this is a sink node. Okay. Okay, next. So in the exam, okay, in the exam, you will see like this, yeah, in Moodle, okay, you will see this kind of notation. Okay. So this is MATLAB notation. So how to see the actual things? You look at the semicolon here, and then you just press enter and copy, press enter so that you will see the actual matrix. Yeah. So separate by comma, and then at the end you separate by semicolon, okay, for each row. Clear? Is there any question? So here, we'll not tell, okay, the name. So we assume A, B, C, D, E. Okay. So in this case, from A to B, that is, right? And then from B to C and D, so D, C, and D. And then from C to E, that one. And then this one is sync node. This one is from E to A and B, yeah, this one. E to A and B. Clear? Right, so you can represent the network into adjacency list and adjacency matrix, yeah. So, okay, practice. Okay, you write down in the notepad and then you share your screen, okay? And then you can get recitation, right? You can claim your own recitation. Yeah. Okay, one for adjacency list and one for adjacency matrix on this network. Go. Now you raise your hand. I will let you share your screen. I'm making the co-host so that you can share your screen. Who is first? Can you put into adjacency list and adjacency matrix this network? You can put it in Notepad or in Excel. Yes, Vin. Let me share your screen. Go ahead. Vin.
Are you seeing it now, sir?
Um,
The notepad.
can anyone see that? Oh yeah, I can see that. Okay. Okay. Let's see. So the network is from A to
A
B.
to B, then B to C, C to E, D goes to B and C, then E goes to A and B of the same weight.
Okay, super. And then, yes, so one, okay, that's correct. Okay, very good, then, yeah.
Thank you, sir.
Thank you. Anyone else want to share screen? Yeah, Glenn. Go ahead, Glenn.
Hi, sir. I can't share my screen.
You,
It's disabled on my part.
well, okay, I make you co-host so that you can share your screen. Go.
There. Can you see my screen po?
Mhm. Oh yeah, okay. Good.
So,
Yes.
for the adjacency list,
Adjacency matrix, that one, right?
for the example.
Yes, yes.
Sorry, it's supposed to be matrix.
Yes.
Sorry.
All right. Okay, very good. That's correct.
The answer is the same.
Yes. Okay. So, yeah, thank you. And super. And, yeah, you want to share?
Yeah, sure, sir. Wait. How's it?
Uh, you're already co-host, huh? Please, you can share your screen. Mhm.
Just the same with others, sir.
The same as others, yeah.
Yes, sir.
Super. Yeah. Okay, good. Okay. So at least
I'll share later, sir.
yeah, okay,
My Google Chrome's not letting me.
okay, so clear, yeah? And look at the column D in your adjacency matrix. In this example, if you look at the column D, okay, yeah, yes, very good. So you can claim your recitation, okay. Later, okay. If you look at the column D, okay, the whole column are all zeros, yeah. Okay, so that means that is source node. You see that? That's the characteristic of source node is in the column, the whole column is all zeros. Yeah. So if you have one row, all zeros, that is a sync node. Okay. If you have one column as all zeros, that means that column is a source node. A source, can you see this column? Node T. Okay. A source means can go out. Okay. The agent can go out from there, but cannot go home. Okay. Only can produce, okay, cannot go home. Okay. Next practice. Can you draw? So, and can you make adjacency list and then can you draw the network? Something like this, nah? So given the adjacency matrix, okay, in MATLAB notation, can you make adjacency list and then you can drop you can drop a hand in any things, or you can use what is that called, IFN at ins last week. You can also put the adjacency matrix, okay, and the node you can throw there. Yes.
Sir, can I share screen, sir?
Sure. Okay, jump in. Go.
Is it viewable, sir?
Hmm.
Here's the given, sir, in matrix form.
A to E to A, B, and then to C, and then to D. Yes.
That's the given, sir. Here's the list, sir.
That is the list. A to B.
Shortcut lang. That's a shortcut, sir. You did not put the curly braces.
Okay, so you need to put the braces, yeah?
Yes, sir.
Okay. Okay, so
Then
you notice
just,
that D is a sync.
yes, sir. No connections like that.
Ah,
I mean,
can
no
go
start
in.
origin.
Yes. It can
D is not
only
an origin, sir.
go in but cannot go out.
Yes, sir.
Right.
Then here's the
Yeah,
drawing.
the drawing, okay, that's fine.
Improvised drawing, sir.
Yes, okay, good. Okay.
Thank you, sir.
Yeah, thank you, Isabel. So anyone else want to share? Who? I'll okay, go. I'll
Okay,
be.
I'll share my screen.
Yes, sure.
Okay, so everybody can see the application. Okay.
A to
So this is
B.
the adjacency list, and then this is the drawing based on the given.
Okay. B to
So A to B, B to C, D,
A,
E,
A,
C to
B
D,
to E, and
and E to A.
E, and E to
A.
E to A. Okay.
Yeah.
Okay, good. And then the list is, can I see?
Here's.
Oh, that's correct. Okay, good.
Thank you.
Okay. Anyone else? Okay. Who raised hand on that? Okay, so let's continue with the next practice then. Okay. Oh, June, you want to show your work?
Yeah, sir. Just try.
Okay, fine. A to B, B to C, and then D, and then E. Yeah. And that is the, I cannot see your can you zoom it a little bit bigger, your adjacency list? Okay. The adjacency list, you need to put the correct bracket. Yeah.
Yeah, sir. This one.
Yes. Okay. Okay, good. So next. Now another practice, those who did not decide. Okay. So can you represent the next network, okay, into adjacency list and adjacency matrix? Yeah, in the slide you can see. Green. Yeah. Okay, can you represent this into adjacency list and adjacency matrix? for those who did not recite. All of you, you can recite again, no problem also. But this is interesting. Okay. Is there any sync or source node? Is there any sync or source node? No, yeah. And then can I go from any node to any other node? Say A, I can go to B, C, D, and then come back to A. Yeah? So this is a irreducible network, yeah, strongly connected. And if you represent this into adjacency list and matrix, you will see there is no zeros in the rows or columns. No zero rows, no zero columns. Anyone want to share screen? Yes, Cap. Okay. Cap and Joven. Go. Cap, you first. Mm,
Sorry, something's wrong with my browser. I'll try to restart it. Sorry.
hey. What's the problem?
Something's wrong with my browser. I'll try to restart it. Sorry.
Okay. So you just type in the chat in that case, Cap. Okay. Next, Glenn. Wow. Okay. Glenn Solina.
Hi, sir. For
Yeah.
this particular one, um, sorry.
Okay.
List is
List is which one?
A is going to B, B going to C and E,
Correct.
C going to D,
Okay. D
sorry,
going
D is going to B,
correct.
and E is
Fine.
going to A.
Very good.
So as represented in the matrix, sir, A to E is 1 here. Sorry, that's A to B, sorry. B to C and E, C going to D, D to B, and E to A.
Super. Okay. Yes.
Thank you, sir.
Thank you. Who else? So Ben. Yeah. Easy, right? Yeah. Okay, Joven and then Vin. This one is the practice 3.
Yes, sir. The matrix, sir.
The matrix is the
0,
same.
1. Lagi.
Let me see.
Yeah.
Oh, 1. Okay, the third one is 1 in the middle. And then the plus and this. Okay, correct.
And the list, sir. I already put the curly.
Okay. Okay, the curly. Okay, Vin Sanchez. Thank you, Joven.
Thank you, sir.
Vin Sanchez.
It's showing now, sir.
Yeah. Okay, so
The same.
the
Except I
same.
used PowerPoint this time.
Okay, this time you use one. Okay. Okay. Good. Okay, thank you. Okay. the way I teach is to give you difficulty first, and then later you will see the tool that make you feel easy. Okay. Anyway, no problem. At this point, let's continue with the next. Where is my there? And go back to string 2. Okay. Oh, do you still need another practice, or this is okay already? Okay, now this time, okay, I want you to practice in the lab, okay? I created a lab for you. Okay, you just copy and paste this part, okay? Or you can just make it like this. Okay, let me see. So go to Moodle. Where is the Moodle? So there. Okay, and then go to this lab of network and matrix. Okay. Okay. Can you see the IFN lab adjacency matrix and graph? So this time you don't need to throw in PowerPoint or okay. So let's learn how to draw the network from adjacency matrix. Okay, and then from adjacency matrix to network. Yeah. Okay. So if you want to know what is graph theory and linear algebra, so you just click that one, so you can go to the actual tutorial. Okay, in here. So this is a picture only in the algebra also. Yeah. So let's go back here first. So this one, how to do is you generate a random matrix, yeah, by clicking the dice. Okay. So then you will see you can do a left click in the pattern visualization to increase the cell. Okay. Right click to decrease the cell value. Okay. And then you can click the network to create a node. Okay. You can drag the line between the nodes to create the links. Okay, and then you can observe, yeah, what will happen to the matrix visualization and adjacency matrix. Yeah, so you can also change the matrix manually in the text area, and you can also change the color pattern and some schema. Okay, after that you can do the experiment. Yeah, so here is the example. Can you see this? Should I make it smaller? Oh, there. Okay. Okay. So this is the tool that we have. So all you need to do is click this random matrix. There. Okay. And then if you want to know the help file, you just click this, and then you will know what is the command. Okay. And then say, for example, I use desktop, right? So I can press the control, and then you can play with this. Yeah. Okay. So a while ago we have this kind of matrix. What? This one. Okay. So you need to copy, okay, and then put it here. There you will get that. Okay. Of course, you can also put into CSV, okay, or you can load it from CSV file. Okay. You can also change the color to traffic color. Okay. You can add say the sum, yeah, in rows and columns. Okay. You can also create new network. So this one I can create 7. Oh, very complicated. Yeah. If more than 5, I think it's very complicated. 5 is already complex. 4 is, I think, quite nice. Okay, you can zoom in, you can zoom out, and you can pan. And this is to draw the network. Yeah. Okay, just I give you some time to practice, okay, and then try challenge yourself to create a strongly connected network. Okay, try to create what is called pre-magic matrix. Yeah, what will happen to the sum of row and the sum of columns? So pre-magic means the pattern of this sum of row and the sum of column will be the same. Okay, and you can also create an ideal flow network, yeah, which is strongly connected and pre-magic. You can also create a complete graph. That means complete graph means from each node you will have a link. Okay, you try first. At least practice this matrix into the network. Okay, so the challenge, yeah. So three challenges, yeah. So number one, this one. Okay. Number two, can you create any strongly connected network? Okay. The more difficult one is, can you make any matrix of pre-magic? Pre-magic means the pattern, okay, of the sum. Okay. The sum of rows is the same as the sum of columns. Okay. Okay. So you have the tools. You can use this tool. I hope this is easier than using annotation in Excel or Word. Okay. Three recitation. Okay, one person each. Okay. One is to get this, just draw this network. The second one is to create a strongly connected network, and the third one is to create pre-magic. Oh, one more if you want. Okay, create an ideal flow network here. So you can easily make like this. Okay, when you click this button, it will go up. When you right click here, it will go down. Can you see? Okay, so I can always put it down. I don't like this. So okay, can make it up and down. Practice. Okay, once you have done, you can share your screen. Is this fun? Oh, you don't have pre-magic in your Windows? What do you mean? Of course you don't have, so you need to make it. Okay, you need to make pre-magic matrix in your in this tool so that you can. I want to see how it works. So definition, by definition, yeah. Pre-magic matrix means the sum of rows equal to the sum of columns, yeah, in the same pattern. Yes, Glenn, you want to share your screen? Go. Which
Sir,
one?
I have a question for the first one first. All we have to do is put the matrix in the adjacency matrix, right?
Correct.
I will share my screen.
Okay, go. There. Let me open bigger. Oh, it will not work because of the first part there. You remove that. Yes. Okay, so 1 0 1 0. Okay. 1, that's correct, and okay, good. Very
Thank you,
good,
sir.
very good, yes. Okay, next. Can you make strongly connected network? And more difficult one is, can you make pre-magic matrix? Yes, Albi.
Sir, I'll try pre-magic.
Pre-magic, you try. Okay, good. This is more difficult. Go. Show. Oh, okay.
So total of left and right.
Is of
So
exactly the
5
same.
should be
Okay.
yeah.
Yeah, this is fine. Okay. So the total
5.
5 and all 5.
Yes.
Okay. So this is magic matrix, not just pre-magic. Yeah. Pre-magic means all the pattern is the same, but not necessarily all the same numbers.
Okay.
Okay. So what you have here is magic matrix.
Ah.
Okay. Good. Okay. Of course, magic matrix is also pre-magic.
Nice.
Super. Thank you.
Thank
Anyone
you.
else want to do a pre-magic? I know this is more difficult than the others. Oh, can you make also pre-magic and strongly connected at the same time? Next challenge.
Sir,
Yes,
can I try?
of course. Sure.
Okay, let me share my screen.
Yeah.
Can
Huh?
can someone stop sharing the screen?
Ah, sorry.
Can share my screen.
Sure, sure. You're supposed to be able to share screen. Come on. Make co-host. Okay. Can you share? Wow. Oh, this is you're trying to make complete network. Right. Do you want to change the color in the sun? You can change it into rainbow, for example. In the color tap on the right. Change it to rainbow.
Yeah, okay, let me pause my screen.
Oh, no need to pause, just
Okay. Ish. I
in the right side there is a color.
okay, here.
Yes, you change to rainbow.
Rainbow.
Yes. And then sum total.
Okay.
Right.
I'm not getting any call.
You don't get any. Oh no. Do you mind to use Google Chrome, the latest one?
Yeah, my Chrome is actually I think I have the latest version
You have the latest
of
version?
Chrome. But
Or
maybe it's my connection, sir.
no, I don't think so.
Let me try.
Oh, there you got.
Okay.
Okay. Okay. So anyway, this is nice. Yeah, you can see the whole point. And you can save this matrix and put to CSV. Probably certain JavaScript is prohibited from your, probably you said certain thing that you prohibit JavaScript, no? I'm not sure. Why me? Anyway, so your screen is your result is okay. Okay. That is a complete network that you just make, right?
Sorry. Can I?
Yes, go. Yes. Who want to share screen?
Can I, sir?
Go.
Or pre-magic again?
Okay, go. Yeah, this is magic matrix. Oh, there. Oh, no, this is not magic. This is not magic. You know why? You can see at the bottom. Okay, I will give you the color here. Let me color it red so that we. Okay, this is magic matrix. But a while ago when you put okay, this is magic matrix. I can see this the same pattern, right?
Mm.
It is a magic matrix. But if you want to put very magic, okay, this
Yeah, it's
this
just
color should
the
be
top.
this one.
Okay, they should just be the transpose of each other.
Symmetric matrix is always pre-magic.
Okay.
Okay.
Okay, I'll try again, sir.
Okay,
Or
okay, fine.
pre-magic.
Yeah, this is magic matrix, yes. Okay. Okay, good. Anyone else want to try? Yes, you probably need to use Chrome. I also use the Microsoft Edge. It's also working, no problem. Safari also working, no problem. But I think you need to use the latest one. The older browser usually do not accept certain commands in the JavaScript. Okay. So then it will not show all. And who else? Anyone else want to can you make ideal flow network? Ideal flow network means, okay, it is very magic and strongly connected. Double challenge. Yeah. Anyone? Yes, Joven.
Sir, I would just like to share and ask what is this?
Okay, okay. Go ahead.
This one, sir.
This is 3 by 3. The
The sums, I don't think. Is it right, sir?
1, 2, 3,
6, then 6 again.
6 and 6 again. Yeah, this is premagic, right? Yes, this is premagic. And this is premagic and strongly connected. So you get the ideal slope.
Oh, so this is correct, sir.
Correct. Yeah.
Okay, sir.
Okay. Yeah. So in fact, now Joven, can you put the diagonal to 0 and
Diagonal, sir.
yes,
Left to right, sir, or how? What diagonal, sir?
diagonal is from the top left to
Okay, I will put 0, sir, all.
yes, you put all 0. Oh, you can do a right click, yes, and then also there you can put 0. Is this still the same? Still premagic, right?
Yes, sir.
Right. So
8,
this is one of the properties. Yeah. Once you make premagic, even if you remove the diagonal, it will still be the same.
Oh.
Oh, nice. Yeah. I have a video there in Moodle, the beauty of premagic. So this is very beautiful mathematically. Okay. You can go deeper. Super. Yeah. Thank you.
Thank you, sir.
Yes. So you got the ideal flow network. Yeah. Okay. So let me continue. Okay. With oh, Win, you want to say something?
Just clapping.
Okay, go.
No, sir.
Ah,
I'm
no.
just clapping for Joven.
Clapping for job. Okay, super. Okay, so then let me go back to the slide. Okay, we have, okay, so in this slide we have a strongly connected network. Okay, a network is strongly connected if there is a path in the network from any node to any other node. Yeah, so this is what I mentioned, that if you go from somewhere, then you must find a way to go home. Okay? So transport network is strongly connected network. Yeah. So the terminology in graph theory, okay, if you have this kind of properties, okay, the network with this kind of property is called strongly connected network. Yeah. In linear algebra, the matrix, okay, the adjacency matrix with such property is called irreducible. Yeah. So this is one word, this is 3 words. So okay, so in these 3 examples here, okay, which one is strongly connected and which one is not?
The third one, sir.
The third one is strongly connected. Okay, the first one, okay, this is connected if you remove the arrow, right? If you remove the arrow, it is connected, but if you put the arrow, it is not strongly connected. Why? Okay, this is called weakly connected. Yeah, weakly connected means the network is connected, but okay, only when the arrow is removed. Okay, when the arrow is there, you can go to D, but cannot go from D. You cannot go to A. Yeah, right. So in this case, A here, nobody can go to A, right? A is a source node, right? And T in here is the sink node. So weakly connected is a network that is connected. Okay? But yeah, correct. Yeah. So there is either sink node or source node. Okay, the four possibilities. The network is connected. There is possibility of having source node, sink node, or source component or sink component. Yeah, I will explain later about component. Okay. This one is also weakly connected. Yeah, there is, what is this? This is the source node, right? This is the two sink node. Yeah. So yeah, strongly connected. From any node, you can go to any other node. So this is the strongly connected network. Clear, yeah? Okay, so network C here is interesting, yeah, because this not only strongly connected, but the flow, yeah, these numbers here, the weight represent the flow. The flow is also balanced. You can check in any node, okay, the number of flow in is exactly the same as the number of flow out. Yeah? 5 here become 4 plus 1. Right? 4 can enter here and then become 2 and 2 out. Right? Here, what is this? 2 plus 1, right? And then go out 3. Yeah? How about this one? Enter 3 and then here enter 2, so the thought going out 5. Yeah? So when you can see the network is strongly connected, okay, and then the flow is also balanced in all nodes. Okay, this is ideal flow network. Yeah. So the balance of the flow represent the premagic properties a while ago. Okay. The number of flow in exactly the same as the number of flow out. Okay. Okay, so before we go to component, can you throw this network, the network C in your tool? So given this network, can you throw in your tool? Meaning that you need to input the matrix, right? Anyone can input so that you can get this. Well, not exactly like this, but you know, the network. Because the coordinate does not really matter, right? In fact, you can use the control and then drag the node, it will change the shape. No? Yeah. In any graph theory, the coordinate does not really matter. It's just to show. The connectivity is more important than the actual coordinate. Can anyone draw this network C? In your tool, in the lab? It's only 4 nodes. Yes, Abi. Yeah, I will stop sharing so that you can share.
Here, sir.
Yes. Oh, let me open it quicker. 2, 2, 3. Okay, very good. Yeah. So you get premagic. Oh, the result is the same, yeah. Yeah, very similar. Okay, super.
Thank you.
Thank you, thank you. Yes. Very good. Okay, let's go to the next subtopic. Okay, it is component. So is this clear? A while ago, the weakly connected. Okay. Next is about component. So now a component, okay, is a strongly connected sub-network. So you have a network, okay, there is a sub-network, subset, right? So look at this example, okay. Network A here, okay, this is strongly connected, right? Okay, from A you can go to D, C, and then come back to A. So, yeah, the same thing. From A you can go to F, B. So the same thing in here. From D you can go to C, D, and E. So we come back. So this is strongly connected, yeah, and A. And then how about B? Yeah, network B here is unconnected. Yeah, you have two components. Okay, each component is strongly connected. Can you see this? Yeah. So this is one component, and this is the second component. Yeah. One component is a strongly connected, yeah, sub-network. Okay. So in here I can also identify this is a sub-network. Okay, I just get the three nodes and then the links. Okay, the same thing here. I can get this one as a sub-network. Okay, so this is a component. Okay. Now what happened to this network in C? Okay. Oh, you don't have any sink node, you don't have any source node, but you have what is this? DCE is a component, right? This is a source component. Well, this one, A, B, and F is the sink component. Can you see that? Okay, from D, C, and E can go to the left, but cannot go back. So, okay, a network with either sink node, source node, source component, or sink component, okay, but they are connected, they are called weakly connected. Yeah, weakly. Is it clear or not? Oh, now, can anyone, okay, create this tree network? Okay, can anyone this chart? Can anyone create this tree network? Okay, so 3 person, yeah, A, B, and C in that tool. Okay, let us see what will happen to the adjacency matrix. Okay, so 3 person, and then let's observe the difference. Yeah, not in the slide. So can anyone create the adjacency matrix for A, B? This is unconnected. Okay, and then the C, weakly connected, but based on component. Okay. Or in the source node and sink node a while ago, you can identify easily using row columns or zero rows or zero columns, isn't it? How about this one? Can you identify like that? It's a challenge. Go, make it. Okay, while you are making it, I'll go to CR first.
Sir, can I share letter B?
Anyone want to share screen? Don't forget your to claim your recitation, yeah, later in Moodle. So if you go to the tools here, and if you click anywhere in the canvas here, can you see? You can also see the additional in the row and columns, yeah, in the matrix, right? So, and then you can also drag, right, example, and then you can put it two-way and redraw. Okay. And you can move this somewhere. Okay. Or you can add directly here in this visualization. Okay. You can add or you can reduce. Okay. So knowing your tools is useful, I hope. Okay, go ahead. Can anyone create a weakly connected network with two components and then unconnected network? Okay. Anyone? It's something like either A, B, or C like this. Yeah. So this part is okay. Network C here is interesting. Yeah. So it has no sync node, yeah, no source node, but it has two components. Can anyone draw this one?
Sir, can I try letter B?
Letter B. Okay, go. Stop here. Go ahead. Yes.
Here, sir.
Okay, let me see. Oh, okay. Can you move a little bit the ABF to the right? Use control button and then drag it. Control button. You did not press control.
Control din this one.
Yes, like that. Good. Now I can see that this is separated. Yeah. Super. Yes. Thank you. Thank you. Glenn, solid enough. So is this?
Sir, I'm not.
Hey.
Sorry, go ahead.
Go ahead. Go ahead.
Sorry, sir, I'm not sure with this one, but I'll try to do the letter C, the weakly
Okay.
connected one.
Okay. Try to do letter C.
I'll share my screen.
Yeah. Go. Okay. 1, 2, 3, 4, 5. You can use control and then move it a little bit. Yes. Okay. Yes. So from ABC and then this one can go. Correct. Good. So you can also change the value instead of 1. You can change any value. Okay. No problem.
Mhm.
Okay. That say for example, okay, you can click that there. Right? So you can also click in the other green areas there.
So the direction still remains, but
They still remain the same.
Yes.
The structure still remain the same. The weight does not actually change the network structure, right?
yes, sir.
Yes.
Copy.
Good.
Thank you.
Thank you. Thank you. Next, Vin Sanchez. Go.
This one, sir, is for the letter A.
Letter A, yeah. Oh,
But I've chosen what all weights of one.
yes. Uh-huh. Can you zoom in a little bit bigger? Okay. Now I can see. Okay, good.
Okay. For the one disconnected network,
Uh-huh. Okay, disconnected also. Oh, you can add. That one is also disconnected, yeah.
I
Good.
haven't last one, sir.
One node is also one component, you know.
Oh.
Yes. Okay.
Okay, thank you, sir.
Okay, thank you. So, anyone else? Okay. Let's continue then. I hope this is fun. Right. Okay. Now, can you identify components? Yeah, just mentioned. Can you identify the component in this network? Can anyone identify the component? Yes. A, B, and E is a component. Very good. How about this one? B, C, and D is also a component, right? Okay. So there are two subnetwork, okay? But don't forget, okay, the whole network itself, okay, if it is strongly connected, yeah. So if this the strongly connected, that means the whole network itself is also a component. Yeah. The whole things is also sub. Okay. So if it is strongly connected network, the whole things, so A, B, E, A, B, C, D, E is also, yeah, B, C, D is also component. That's correct. Okay. Clear, yeah? Component. Yeah, these are the two, okay, including the whole network. Yeah. Okay, practice now. Can you identify the component in here? In this example. Anyone? How many components do we have here? A, B, E, that's correct. C, D is also component. Super. Yes. Okay, so you identify two components. The whole network in here, because this is weakly connected, okay? The whole network is not a component. Yeah. So you have only two components, A, B, E, and then C, D. Super. You understand that. Okay. So this is the first component, A, B, E, is a source component, isn't it? Right? And then the CD is a sink component because from the source can go to the sink, and from the sink cannot go back to the source. Right? Clear, yeah? So a while ago, okay, when you see the node, okay, you can see row of zeros or column of zeros. Yeah? But when it is component, you cannot actually identify easily based on the matrix alone. Yeah. Okay. So you need an algorithm to compute that, okay? Or you can see visually in the network. Yeah. Okay, how about this one? Can you identify the sink component here? Yes. So yes, correct. Okay, so B, C, and D is actually a sink component. Yeah? So the component can overlap. Can you see? How about this one? A, B, and E is it component? No, right? Because from A go to B, we cannot go to E. Yeah? So this is not a component. In fact, E itself is a source node, right? Node E is a source node. So we have only one component, which is B, C, D. Okay. Okay, BCD, okay, is from a component. Yeah? Within that component, you can go around, okay? But cannot go out from there. Yeah, it's a trap inside that component. Yeah, BCD in fact in here is a sink component. Good. How about this one? Can you identify the component and what type? Okay, is there any source component? Yes. Okay, A, B, and E is a source. Very good, yeah. Okay, and How about node T? What is node T? Node T is a sink. Can you see? It can go here, but cannot go out, yeah? Node T is a sink node, very good, yeah? So there is only one component, yeah? In this example, only A, B, and E. This B, C, and D is not a component, yeah? In fact, D itself is a sink. Remember, component must be strongly connected. Is it clear or not? Okay. How about this one? Can you identify the sink node? Oh, that's easy. And then can you identify the sink, the source component? Is there any source component here? Yes. A, B, C, and E itself, yeah, become the whole thing become the source. Very good, Mark. Yeah. So A, B, C, and E, it can go around here, right? So this is one component, yeah. Well, D itself is a sink. Is it clear now? Yeah. So T is a sink node. Yeah. Once you enter here, it cannot go out. Okay. Well, the other is the component. How about this one? Can you identify the source node and the sink component? Okay. Right. So anyone can identify the source node and the sink component? Yes. Okay, the source node is D, very good. Okay. And yeah, LP, correct. And then yeah, the source node is D, and then the component is this, yeah. A, B, C, and E. Yeah, is a component of C. Okay. So remember this, yeah. Why we are talking about this all node, source node, okay, sink node, okay, source component, sink component, yeah, because later on, okay, when you see your own network, okay, you identify later, yeah, oh, I have my network apparently not strongly connected, right? So then you need to identify which one is your sink, or there must be any of these four. Okay, if your network is not strongly connected, okay, but they are connected, that must be one of these four, with this source node, okay, sink node, or source component, or sink component. These are the only possibilities, right? So in that case, how do you overcome that? Okay, simple, yeah. One way is to connect the sink. Okay, if you can connect the sink node to the source, okay, by adding a dummy link, then suddenly become strongly connected. Okay, the same thing, okay, when you have a component, okay, so each of these node in the component, say sink component, you connect to the any of the node in the source component, it will become strongly connected. So identifying this is important because later you will use it. Okay, because your network is supposed to be strongly connected, yeah. But well, I did not get strongly connected. So then identify the component or the source node, okay, or the sink node. Okay. Okay. Practice. Oh, how many components? Many components here. Okay. So can you identify the source component and the sink component? Yes. The sink component is none. Really? There is. Okay, the FG, okay, anywhere A. So A, B, and E, okay, A, B, E represent one component, right? Can go to FG. Yeah. FG is the sink component, yeah. So once you enter the sink, cannot go out. Okay? From here, you can only go out. Yeah. Inside or go out, but cannot go back. Yeah. So in this case, A, B, and E is a source, right? How about this one? C, D. Okay, and then with H, C, D, and H, what is this? Oh, this is intermediate. Yeah, this is not source, not sink, right? Okay, so not all components are sink or source. Okay, so you can go in, you can also go out. So in this case, C, D, and H is just normal, normal component. Yeah, it's not sink, it's not source. Yeah, intermediate. So don't forget, C and D itself is also component, right? And also D and H is also component. And then C, D, H is also component. Okay? Yes. Very good. I hope this is clear. Okay. So up to here, is there any question? Network representation. Is it? So, oh, one thing I did not put in this slide is about the latest one, yeah. The latest one. So you can go to the Moodle. Oh, yeah. There is a IFN lab of composition decomposition. I hope you can see. So another representation, this time is only for strongly connected network. Okay, can you see this? Okay, go to IFN lab of IFN composition decomposition. So in here we are using string instead of adjacency matrix and adjacency. Okay. Now we are using string. This string represents a cycle. Okay, maybe I need to go back first here. Wait, what is the name of the lab? Premier. On there. Yeah, okay, so there is a lab here called Premier Network in Moodle. Yeah, I will open this. And there is a game if you want, so that you can understand. Okay, I will open the game also. So the Premier Network first, so that you can understand this. Okay. So if you click this tools, okay, you will create any matrix of any size. So I put size 7, okay, any matrix, random matrix here. Okay. So let's say go back to 4. Okay. So this is any random matrix. Okay. And now any random matrix which is strongly connected. Okay. If you want to know it is strongly connected or not, we check, right? If it's reducible or not, right? Oh, the matrix is reducible. That means strongly connected. Okay. So then you can get the cycle. Okay, these are the cycles. Okay. You can create a cycle in this network. Yeah. Oh, what happened to this? Oh, this is unconnected. Unfortunately, unconnected. Okay. This is supposed to be irreducible. Okay. Oh, sorry. I'm connected because I did not make this. Okay. Okay. So if you have this matrix, okay, and this is actually irreducible matrix, okay, and you can see there are many cycles that we can create, okay, based on this matrix alone. Yeah. So if you want to see the network, I will just copy this and then put it here, right? And then throw. There. That is the network. Because this network is only on the right side. So you can see I can create a cycle. Okay. So A itself is a cycle because, of course, this is a self loop. Yeah. Anything with the self loop is a cycle. A, B, C is a cycle. Now A, B, C, from A, I can go to B and then C and then come back to A, right? It's a cycle. Next cycle here is A, B, D, C. Okay, let's see. A, B, and then D, and then C, and then come back to A. Yeah. So this is a cycle. Yeah. So, and then the last, AC. That means AC, A to C, and then come back to A. Is that correct? A to C, and then come back to A. Yeah. And then the last cycle here is CD. That means from C to D, and then come back to C. Okay. So in this premier network, you can add now. I can add. I can add. So this lions here, if you click this, you will add. I will add all the cycles here. Okay. Then if I add all the cycles, okay, then I will get this pattern. Yeah. This is always premagic and always irreducible. Yeah. So you can check irreducible, yes. Premagic, yes. Okay. Of course, this ideal flow. Yeah. Clear? Yeah. So now by creating a cycle, okay, and then all the cycles in this original matrix, you will always create ideal flow network. Okay. By adding, so you can also play what happened if, okay, I will delete all. Okay. What happened if I use permutation as my cycle? Yeah. The same cycle here, I can use it using canonical cycle like this, or I can use the permutation. That means, look at this in here, ABC, right? So in the permutation, ABC can be ABC, can be BC, from B to C to A, right? And then can be also from C to A to B, isn't it? Because it's a cycle, so which one you start doesn't matter. Okay, when we say permutation, that means any node can be the starting point of the cycle. Yeah, when we put canonical here, that means only the last node value, which is A, should be the standard naming of the cycle. Up to here, is it clear? Okay. Now using this canonical cycle, okay, now we can come back to this earlier composition, decomposition. Up here, this lab. Okay. Now, using this canonical cycle, I can create. Remember, if you have a cycle, okay, and you can add with any other cycle, and you will always create ideal flow network. Okay, so you can create random cycle. So the here is A, B, C, D, and when you put like that, it will always become ideal flow network. Yeah, you can see the pattern here is pretty much it. Yeah, in this case, exactly magic matrix. Yeah, so I can create another, and then click this arrow. Okay, and then you will see this is also pretty much it. So in fact, you can check is reducible always and always pretty magic. So of course, this is ideal flow, right? So you can get from here, you can get the adjacency list. You can get total flow. Okay. You can get back the network signature. Okay. They are not always equal. Okay. So you can get back here and get exactly the same. Yeah. This is equivalent network signature. So my point is you can represent the network is in adjacency list, in adjacency matrix, or in the network signature as a string. Is this clear or not? Okay. So what is this string? This string represents the cycle. So in the game, okay, so in this game, can you see the game? So say I create a new game. Okay. So your goal in this game is to create very magic matrix, okay, by setting the coins. So okay, so you look for the cycle in this matrix, okay, and this is the actual signature, okay, and you're supposed to create so you can click here, okay, you can click this one, okay, so that it will become this signature. Okay. So of course, if you want to get the result, okay, you can just get the actual result. Okay. So the correct answer is in here. Okay. Look for it so that you can get the actual signature. Okay. So and then you can either increase or decrease the value. For example, this one I reduce. Okay. You can also increase directly with certain numbers. Yeah. Okay. Instead of 2, I can directly increase with 5. Okay. So yeah. So reduce with 5 or increase with 5. Okay, anyway, so come back to the network representation. So 3 things, yeah? Adjacency matrix, the adjacency list, and then using the strings. Okay, up to here, is there any question, comments? Okay. So if not, we can go back to Moodle and go to the next slide. Yeah. About pedestrian. Can you go to Moodle? And then go to this slide, yeah, pedestrian win business. So, okay, pedestrian win business. Okay, we will go to the actual transport supply. Okay, but I will give like introduction first. So pedestrian network, you can apply to any. For your project, you can also do this. So don't forget, we are all pedestrian at certain point in time. Whether you are using car, using public transport, right? Using an airplane, okay. Whether you are using motorcycle, okay. You are always pedestrian at certain point in time. Okay. So now, what we are often unaware is that you yourself are pedestrian at some point in time. Okay. So the problem is the restricted point of view. Okay. What is pedestrian? Okay. So people think that pedestrian is only people who walk or crossing the street. Okay. But you need to think pedestrian is not just a person who walk on the street or in the crossing the street, okay, but they are also person who move or travel on foot, right? So, or they also use assistive device, yeah, propelled by human power or mobility. So that means what? That means all of this, yeah, if you are jogging, okay, you are also pedestrian, right? Mother with a trolley of the baby, they are also pedestrian. When you are waiting for the movie or going in the airplane, this is also pedestrian. Inside the building, also pedestrian. Children in the playground, they are pedestrian in this point. And even if they are playing outside, they are still pedestrian. Not necessarily walking. And inside the mall, you are pedestrian, right? So, and you are going to the parking lot, or from parking lot go to the building, you are pedestrian. Okay, so pedestrian is more general than you think, only in the sidewalk. I don't like the term sidewalk. You probably better use walkway rather than sidewalk, because side mean look like you are just side, not the actual main one. Okay, so people with disability, wheelchair is also pedestrian. Okay, waiting for the bus, they are also pedestrian. Okay, but using bike or rickshaw, they are not pedestrian. The person is pedestrian, but this is not pedestrian by definition. Okay, or using beca. So I said why pedestrian is important, because this is actually the largest group of road user. And everyone is pedestrian in some point in their trips. Okay, and in fact, okay, walking will connect car to public transport and public transport to destination. So, okay, from the train to taxi, from the bus stop to destination, from the car park to destination, you are pedestrian. Okay, so in that case, you need to people who walk. So you need to think in terms of design. Okay, it's a problematic because you don't provide the walkway for people from the car park to destination, example. Okay. Pedestrian or walking should involve all transport of mode, all socioeconomic group and all ages. So, so you need to start to think, how about the design that is universal, that actually used for all people, including disabled people. So, and in fact, there are many places that only pedestrian can use, inside the supermarket, inside the tall buildings, okay, and certain downtown arcades that can also use auto-free zone that can only be used only for pedestrian. Yeah? These are in Japan. This is in Vienna. Yeah. I forgot where is this. Okay. So now when we think in terms of pedestrian in the mall, for example, or in the supermarket, okay, as business becoming more competitive, yeah, to stay in the business, yeah, so you need to think about better knowledge in shopping behavior. Okay, now shopping is represented by pedestrian workflow, pedestrian behavior. Okay, now if you can track this pedestrian behavior, okay, then you can start to think in terms of business, okay? Because pedestrian flow means demand for business, isn't it? Yeah. Imagine you have a mall, okay? How large is the number of pedestrian flow there? Okay? Then the larger represent more demand. Okay? And when the pedestrian stop in certain shop, okay, looking at the display in front of the shop or inside, okay, then how long they stop there represent how long is the longer mean more attractive. So their attention is important also, right? So below certain crowd threshold, okay, so there is a positive correlation between the number of pedestrians and the number of sales, right? So there is also positive correlation between the length of time that people traveling around and the number of sales, isn't it? So that means there are certain layout arrangement, okay, that will produce higher probability for the people to buy. Okay? So the traditional approach to business, usually they just count the number of visitors. Yeah? The counting means flow. Okay? When you count, the same thing when we apply to pedestrian, you can also apply for car for the road network. Yeah. So counting means flow, right? Flow means demand. Okay. Of course, the bigger road, that means bigger demand also. The same in the mall, for example, there are more pedestrian flow that means higher demand. Okay. But the newer approach is not just counting, but tracking. What's the difference? Counting means you get the number of pedestrian in front of you or passing certain door, right? But tracking means you track individual journey, okay, inside the mall or inside the supermarket. Okay, the same if you track the car, you use GPS, for example. Okay, so if you can produce the trajectory based on the tracking, you produce the trajectory based on GPS, mobile phone, RFID, or you track using camera, for example, multiple view. Okay. So you can get the trajectory of pedestrian or the car, so on. Okay. Based on that, that means you have what? The demand over time and space. Okay. So not just the flow, but you can also see the demand over time and space. Okay, and this is very interesting because tracking or trajectory produce better information for us. Okay, basically trajectory is a route data that the shopper will pass, for example, in the mall. Yeah, so then you can aggregate, isn't it? From trajectory individual, you can get the flow. Yeah, and then from that flow, now you can aggregate which part of this is actually attractive alley. And then from there you can make the detailed demand. Yeah? When you change certain items in the shop, okay, how the flow pattern will change. I hope by learning this, you probably get some idea for your own research. That's my goal here. Okay, so but this is also a culturally sensitive problem. Yeah, how do you track? Okay, okay, or you can use expensive gadget, okay, or require certain advanced knowledge for its utilization. Okay, and in developing countries, if you want to track, okay, each individual inside the mall, that's so you distribute the RFID, for example, and you track them. This also labor cost. Sometimes labor cost is actually cheaper than electronic device, then it's a problematic. Yeah. So then the question is, can we actually use questionnaire survey? Okay. Or we can develop a device to automate the process. Yeah. So with my students, long time ago, okay, they created a mobile phone, okay, device, and then we track the people, okay, by stalking in the morning. So we follow the person movement. Okay, but in this slide, okay, I show we can also do using questionnaire survey. Okay, very simple. So to understand that, we need to define what we call ordinal trajectory. Yeah? Ordinal means there is an order. Okay, so we track the pedestrian route, only the path in the business environment. Okay, or sometimes I call this static trajectory. Okay, the problem is we don't record the time. Okay, so the exact time is not considered important as the sequence is. Right? The path is more important than the exact time. So with this, okay, we can assume that the total study time period is the same, yeah, both for static and dynamics, and then you can aggregate this. Yeah? Okay, let's do some tutorial. You can do it in Excel. Is that okay? So suppose this is your supermarket. Okay, and you have an entrance here and an exit there. Okay, and then you ask the person in the exit. Okay, hey, do you remember? Do you want to do this questionnaire survey? If this person said yes, do you remember how do you move in that alley? Okay, so then you can ask the person to do something like this. Okay, the person need to draw their movement. Yeah, in the questionnaire, okay, the person just need to draw their movement. That's it. Okay, meaning you track already the person's movement, isn't it? Is it or not? Okay, so now the question is, oh, if I know that person's movement, how can I get the flow, isn't it? How can I get if I can track this movement of the person, okay, how can I get the flow? Oh, easy, you can aggregate, yeah? So this is pedestrian number, yeah? Pedestrian number 1 is the blue one, okay, pedestrian number 2 is the red one, right? And then what you will do, okay, from this alley, this is supposed to be the shelf, right? From this is the shelf. So what you need to do is to create the alley. Okay, this is the alley. And then you can create any graph. Okay, any network a while ago that you already made. Yeah. So to connect, okay, the alley. So here you give name and name, and the coordinate system is also any. I just put here is 0, 0 anywhere. So I put it in the left bottom left here. Okay, and then I give any name here. So A, B, C, D until L. Yeah? So these are the name. Okay, and to represent this network, I need to get the X and Y, right? So I just measure here manually. Okay, so for example, A is 12.5 and 5.5. Then B must be the same X 12.5, and then here is 7.5. Yeah? And then here is supposed to be 15, and so on. Okay, based on this, you get the coordinate, you can draw this network, the one in red. Up to here, is it clear or not? Okay, once you have this graph representation of the array, okay, you can create adjacency matrix, right? Once you create the network drawing manually, you can, because you know the network, you can create adjacency matrix. Is that correct? Okay. Now, when you know the adjacency matrix, okay, you can also get the path. Yeah, you can also get the distance matrix, right? Oh, the distance is issue between A to B a while ago. So A to B here is 5.5 and 7.5, so it's 2 meters, isn't it? Huh? Because this is the same X. This one from B to C, what is this? 15 minus 7.5, so should be 7.5, right? This is the one that you decide on your own, so you can create. Okay, so this one, 7.5, and so on. So of course, the distance matrix and the adjacency matrix is binary, so 0 and 1. Distance matrix is the weighted adjacency matrix. Is it clear? So then you ask, oh, what is that for? Oh, we can use this for analysis, yeah? So because once you have the distance matrix, okay, you can calculate, okay, the shortest distance matrix. So the tool I can give you later, okay, but from what is the meaning of shortest distance matrix? The one in this red numbers are the actual distance matrix. Now, if I go from A to C, right? If I go from A to C, this is 9.5. You can see from A to C, I must go to A to B first, and then B to C. These are the shortest part, isn't it? Otherwise, I can go to D and then E and C. I think it's longer, right? So by creating the shortest matrix, okay, shortest distance matrix here. So then you can see, because this is strongly connected, so I can see the whole matrix is full. Yeah, these are just the number to get what is the value from A to D. From A to D 4.5. 4.5. What is that? A to D is A to B first, and then B to D, isn't it? Yeah. You find the shortest, yeah, distance from any point to any other point. That is the meaning of shortest distance matrix here. Up to here, any question? Clear? Okay. Now, once you have all of this, okay, you have the trajectory. So look at this. Trajectory represents the utilization, the demand, right? The utilization of the network. While all of this a while ago, the distance matrix, the adjacency matrix, okay, including the shortest distance matrix, this represents the network structure. Okay, whether there is pedestrian or not, whether there is a car or not, the network is there. Then this shortest distance is there, right? Based on the network. It doesn't depends on the person, not depends on how you utilize the network. Okay, it's just based on the actual structure of the network. Can you start to distinguish between network structure and network utilization? Okay, so once you put the demand, which is the pedestrian in this case, then you start thinking in terms of utilization of the network. So in this case, only these are the flow, isn't it? In this case, you have two. In here, I have one only. Here is one, and this one in this alley have no flow. Okay, how do you get that? Okay, so of course, all you need to do is to put this pedestrian in terms of trajectory. Okay, yeah. So the drawing of the pedestrian, now you put it into the trajectory of the node that you put a while ago. Yeah. So here, pedestrian number 1 is the blue one, right? So from A go to B and then go to D. Yeah. Oh no, no. Pedestrian number 1 is the that one. So A to B and then to C and then to E. Yeah. Supposed to be only half, so, but you don't put any nodes here, so this one you put until D and then come back. Yeah. Okay. So pedestrian number 2 is the blue one. So A, B, and then D, and then F. Okay. Of course, the drawing is not so nice, but you need to get the tracking based on trajectory in graph. So up to here, is this clear or not? So once you get the trajectories in graph, okay, then you can get the put that into Excel, right? This is the first trajectory, this is the second trajectory, right? So I just copy from this one. Okay. All I need to do is just put this into Excel, okay, to get the flow. Yeah. So this one, you can use check if this trajectory in graph or not. Yeah, you can use maths and then is number and then use pen. Yeah, and then check whether they are true or not. Yeah, so you can check that all true. That means they are in network, right? And then you can start to count. Okay. So you can use count if they are in the network. So you count the number of okay, in its link is there. Okay, for this pedestrian number 1 and this is for pedestrian number 2. And then of course the total of this becomes the total flow, isn't it? So now you get the link flow, okay, out of this trajectory on graph. Is this clear or is it not clear? You want to practice? Huh? Okay, let me finish first so that you can practice later. Yeah. So once you get the adjacency matrix and you know the flow, right? Then you can put up now become flow matrix. Can you see this? Yeah, this is the drawing of the flow matrix. Okay. So of course you have only 2 pedestrian and many zeros. Okay. So these are the flow matrix. Okay. The flow matrix represent the what? The utilization, the demand. Okay. So you can draw that flow matrix in the pattern. Yeah, so you get the flow pattern. So the bigger, the thicker represent more flow. Okay. And yeah, be careful, this is graph, not the graph in this example. So the empty, it is still 0 here. Yeah, and I plot this matrix into the graph. Okay. And these are the flow pattern. Yeah, of course there are only 2 pedestrians, so not so interesting, but you can start to see the flow. Okay. So then what is alley attractive time in that? We just put that flow into a number which is 0 to 1. Yeah. So based on the maximum flow. Okay. So that will become 0 to 1. Okay, now I will demonstrate to you a real world case study. Yeah. So the paper is in 2009. You can get that paper in Revoledo. Okay, it was in one supermarket, hypermarket in fact. Yeah, we use inventory survey with a questionnaire. Okay, one part is trajectory of each shopper in the hypermarket, and then shopping behavior. Yeah, so socioeconomic activities in the mall and what they buy and so on. So these are not so interesting part. Yeah, the first part is the one that interesting in our case. Yeah. So this is the actual inventory survey. Can you see? The entry and exit is in here. There is a and W here, the toilet here. There is a drugstore, cafeteria, and these are the areas. So these are the clothes, groceries, yeah, and there is a fresh juice, fresh product here, fresh chicken, fast food, and fresh meat and bakery. There's furniture here, also some toys, and so on. So these are the alley, quite big. Yeah? Okay. There are some cosmetic and so on. So these are the inventory survey, and the student did these things. So these are the areas based on the inventory survey. Okay, and these are the example of one shopper. Yeah? This shopper number 168 or something. So this is the one that they draw. Okay, they enter here, they go in here, and then they go out in this cashier. Can you see this? Yeah, this blue part is the trajectory of the person. Okay, and we have many static trajectory, and we have the network graph, and we compute. Yeah, we compute the distance matrix, and from there we can get all shortest path distance matrix a while ago. Okay, and then we can get the statistic. Yeah, and then we get the network utilization. Yeah, what is the actual walking distance? Okay, and we can also get the flow pattern there. Yeah, and then we can compare. Okay, we can compare the median ratio and the product spatial preference in this case. Yeah, let us see. So this is the graph. Okay, model based on the inventory available. Yeah, the students apparently forget to put notes here. So and then because this is everything is already done, so then he just put different name. Yeah, this on 1A, 1B, and so on. This is just because he forgot to put name. So then we add these notes, and the number of X and Y is determined based on the actual location. So with this, we have 88 nodes and 139 links. Yeah? All two ways except in the cashier. It is one way, just going up. Okay. Next, we can plot. Okay, the distance matrix is 88 by 88. It's quite big. So I just color it. Okay. So and then to show you the numbers. Okay. So example here. So infinity mean from 1A to 1B, there is no path. Yeah, there is no way to go there. Right. And this is non-symmetric because the cashier. Yeah, these are the represent the cashier. Okay. So if I just get this part of the distance matrix, which is 88 by 88, this is the example of the numbers. Yeah. Okay, and then I can plot also the all shortest path distance matrix. Okay, there is an algorithm called Warsha that you can calculate all. Yeah. I have the tool there that you can directly compute this. Yeah, and this is the result. Yeah, the result is something like this. This is from all to all. Yeah, from all node to any other node. And from there, we can calculate the shortest path, the statistic, right? Because we get all these numbers, we can get the the statistic, yeah, all pairs of those path. Okay, there are 7,000 plus path, number of paths, so this is the median. Okay, 36 meter. Yeah, the maximum is 123 meter. Yeah, in meter, because this is the actual distance. Okay, and because of the many numbers, so I can plot the distribution. Can you see? This is the shortest path distance distribution. Interesting, yeah? We can, from the questionnaire alone and the inventory, we can already get the distribution. Okay, and we can also detect the outlier. Okay? And then we map the trajectory into the network graph, right? So this is the example of the trajectory a while ago. Okay, in this case, we need to say this is pedestrian number 160. So we need to put all this into graph. Yeah. So 1A, B, and so on, okay, until the end. Okay. So manually, this one is doing manually. And the student do all this work manually. Anyway, number of pedestrian is only 188 pedestrian that willing to be the samples. Okay, and interestingly, okay, because we already know the link in the network, we can calculate the actual walking distance, isn't it? We can calculate the actual walking distance based on these links. Okay, and you see the median is actually 260. Yeah? This is actually 7 times. You know? Median ratio is actually 7 times. Yeah? So we can check the median length of walking distance, the actual walking distance, based on what they report, and compared to the shortest path. Okay, this is actually 7 times. So 7 times longer when this is shopping. Yeah. Okay, people like to shop. When we do the questionnaire survey, do you like to walk this long? They said, no, I don't like. But when actual behavior and during shopping or inside the mall, they actually walk 7 times longer than the ideal shortest path. So, okay. So that's conclusion is simple. Shopper do not walk in the shortest path. Yeah. Okay. And yes, we know this hypothesis. Yeah. But the indicator here represents certain things that we can quantify. Yeah, this common sense, right? Oh, it's not 2 times, it's actually 7 times longer. Okay, and then we can get the flow matrix, right? So because we get the flow matrix, this is the pattern of the flow matrix. Okay, and then we can plot the flow and put it into the inventory of and you can start to see very interesting behavior. Can you see this? Okay, this is the pattern that the main road is people is going directly here. They are not going in the back, they are going directly here, and then queuing in front of the cashier from this side. Okay, here they are buying. Oh, apparently most people are buying attracted because of the bakery. And interesting part, nobody buying furniture, bed cover, shock, t-shirt. Can you see that? This is business intelligence, isn't it? Based on flow alone. Simple. Interesting or not? Huh? So you can start to see that, oh, they are not buying this clothing part. So we're supposed to change this. Okay. So from here, we can get the LA attractiveness index. Okay. And these are the outlier. This is the outlier. Okay. So we can check the correlation between LA attractiveness index and the shopping inventory. Okay. So the major road, of course, this is what they want to buy, and apparently people buy daily usage product, yeah? Food, cosmetic, groceries, and they are not buying all of this. Rice cooker, stove, wet cover, and so on. Okay. So these are the simple conclusion based on a very simple survey. Okay, so I hope this is interesting enough to give you some introduction. Okay. Very simple, but quite novel, isn't it? To collect trajectory based on questionnaire survey, and then you can analyze the shopping behavior and then get the flow out of that. Yeah. Important point here is to distinguish between a network flow and network utilization. Network structure and network utilization. And yes, shopping walking distance inside the hypermart is actually up to half kilometer. Okay? Below certain things is considered outlier. Okay? But this is specific for that place, of course. Yeah? But the fact that they walk 7 times longer than shortest part is a quite interesting conclusion. Yeah. So you can continue this study, you know, or you can check, for example, which array will get more flow than the others, and what will happen if you design the flow layout change. Okay, which one will produce better income, right? Okay, which part of the store will have higher flow? Okay, and if you are the mall owner, okay, you rent the space, isn't it? So that higher flow represent the higher rental fee supposed to be, right? So in this case, you can start to do consulting job for the mall also, not just for the government, right? I hope this is useful for you. Okay, and this is in London. So we do the survey similar. Okay. And we start to get the LA attractiveness index in the pedestrian only road, and what is the impact. Yeah, this and the red one is a pedestrian only streets. Yeah. So is there any pedestrian only street in your city? Not yet. Oh, still car friendly, not yet pedestrian friendly. So do you know what makes a city like PGC, for example, very attractive? It's because they put pedestrian walkway. The same thing in Singapore, for example, you go there, you can see all roads have a pedestrian walkway. In Japan also, right? In fact, in Japan, it's like a one-to-one, right? The length, the road width, and for the car and the road width for pedestrian and bike should be equal. That should be in the law, right? So by recognizing pedestrian behavior and activities, okay, how they use the facility, and when they will use, how long they will spend in certain location, okay, and what type of people they are actually using, then you start to check different behavior. Yeah? You can also check several of my research. We also collect using mobile phone, because mobile phone nowadays using inside have accelerator, right? Okay, so then you can use all of this inside. We can detect whether you are running, standing, sitting, climbing, using elevator or not. Based on that, you can deduce whether you are young, old, disabled or not. Okay? So pedestrian also inside the airport, you can start to see the airport control system, how to make it better. You can also do. Yeah. So can I give you this assignment? So you can create a layout or any supermarket and so on. As you can mark entry and exit points, and then you create a diagram. Say just at least 10 nodes and 10 links. Okay, and then you can set the coordinate system, create the adjacency matrix and distance matrix, and then you draw on your own, yeah, 5 pedestrian, for example, and then project that pedestrian to the graph, and then compute the alley attractive index based on the flow and get the walking distance. Yeah, exactly the same as a while ago. So is it okay? Yeah. This is the paper. Yeah? Question. Yeah, with the assignment, probably will make you think. You can practice or any question, feedback. Yes. When is the two you want? 1 week, 2 weeks? Okay, so use this, right? Okay, I can give you 2 weeks. Yeah. So today we finish this agenda. Okay. So this mean next week no more unless you have question. Okay. And next week, please, you have a group network, group project presentation. Okay. And then we continue with network structure, network utilization, and the relationship between the two. Yeah. Yes, someone asking. Oh no, don't conduct any survey in the assignment. The assignment you just throw on your own, okay? If you want to conduct your own survey for the real things, real world, yes, you do it for your thesis or for your project. I don't know. It's up to you. But for the assignment, it's just practice only, so that you know what is that. That's it. Okay, it's not really important to get the real data at this point. Deadline October 11. Okay, no problem. October 11. Okay, 3 weeks. Okay. Okay. 3 weeks pa. Only for this. Yeah, you can assume the layout and pedestrian flow. So October 11. Sorry. No problem. Okay. What else? Yeah. So assume the layout and pedestrian flow. Challenge yourself. Okay. I hope this is interesting enough for you. Okay. Give me feedback. What did you learn today? Say something interesting on. So you learn how to represent your network, right? You know what is a sink node, right? Source node, okay, sink component, source component. Okay? You can represent the network in adjacency list, adjacency matrix, okay, on also string. Okay, and we start introduction, okay, about what is pedestrian, okay, and the importance of pedestrian, especially for business. And then you can start to analyze in very simple way, okay, to get the actual flow from the tracking. Okay. The coverage of the presentation. I will post the coverage in Moodle. Okay. So yeah, at that point of presentation, you're supposed to know what is your topic, I hope. Okay. And then where is your study area? Whether you want to do paper or you want to do some project animation. Or, so you make decision basically. And most important is the unity within your group. Okay, so with that, thank you very much for today. Any question? Comment? Critics? No. Thank you very much. I will close this.
Thank you, Prof.
Yes.
Thank you, sir.
Yes, sir.
Thank you.
Thank you, sir.
Yes.
Yes, sir.
Is it fun? Yeah. Thank you.